Hello everybody, today we are going to talk about overloading functions and we'll train a bit functions. First, let's imagine a situation like that. I want to write a program that will be able to raise to the power of some kind of the number. Let's write something like that. 2 raised to the power of 3 is equal to, that thing is called base. That thing is called exponent. And when we want to raise 2 to the power of 3, we have to multiplicate that guy here, the base, 3 times by itself. So I have to multiplicate 2 by 2 by 2. I have to do it 3 times, and I have to multiplicate that guy here. And why I'm saying this? Because we want to write function that will be able to raise to the power of something, okay? And now, what will return our function? I think it can return the integer number, and we'll call it power, and it will take 2 integer numbers, the base and, of course, the exponent. Okay, we have the declaration of function. Now we'll create the definition of function. So, let's call that guy B from base and that guy E from exponent. Okay. And how to do that? Well, we have to multiplicate that many times that guy here, right? So let's do it in loop, of course, because it's a very good idea to use loop here. And we are going to use the while loop this time. So while, for example, A is greater than 1, we are going to multiplicate what? B equals B multiplied by what? We want to multiply it by the base. Right now we have base here, but we are right now assigning something to the base. So we are overwriting that guy, right? That won't be the base, because when we multiply, do something like that, we would have, for example, here 4, then we would multiply 4 by 4, and then it would be 16 here, and 16 multiplied by 16. So we have to have the base somewhere stored. So let's create a temporary variable and assign B here, and we'll do something like that, right? Okay, and now that condition will always be true, we have to decrement that guy, and as you can see, exponent is telling us how many times we have to do something, right? So it's a very good idea to use it as a condition. Okay, so let's see. We have to return the value at the end. And let's use that guy, cout, power, and for example 2, 3. So the result should be what? 8, right? As you can see, the result is 8, so everything is working fine. Well, we can write it a bit more confusing, but it will be having less instructions. We can do it that way, because this is the post decrementation, right? And we can, of course, use here something like that operator, which means the same like that, of course. So it's a good idea to do something like that. Let's see, it's working fine. Everything works fine. Maybe let's train a bit before we talk about overloading functions, other things like that. Let's imagine what would happen if I were PC right now. So, I am PC. Hello, I have to include the IO stream, I have to use the namespace. And hey, I have the declaration here. So it means that I will have somewhere in our program the label power, and it will take 2 integer numbers and it will return the integer. Okay, so I know that there will be something like that. Then I am going into the main function, and hey, I have to send to the output the result of the function that got invoked here. And it got invoked with two arguments, 2 and 3. They were sent here, so they were copied to the variable int b and variable int a, and here we are making the temporary variable. Well, let's maybe do it in the comments so it'll be easier to follow. Temporary is right now what? Maybe let's temporary is right now 2, right? And what's going on? We are checking the condition. If e, which is right now 3, is greater than 1. Yes. And after checking the condition, I am decreasing that guy. Bach. Okay, now we have to assign to b, which is right now 2, multiplied by temporary, which is 2. So right now b is 4. Great. And what? I have to check condition again. Is 2 greater than 1? Yes. So I'm going to invoke that instruction after it, but we have to first decrease e. So right now it will be 1. And I am multiplying the b. So right now b is 4. 4 multiplied by temporary, which is 2. So right now b will be 8. We are checking the condition. If a, which is 1 greater than 1? No. So we are not going to invoke that instruction anymore. And we are going to return b to that place. So right now here there is something like that. Okay, and we are returning the 0 and everything works fine. Great. Okay, so we just trained a bit, and hey, I would like to send, for example, something like that. And Bach. We can't right now raise to the power the double number, right? The real number with the dot, right? So, we need another function that could take the double. You know, we can't have two functions with the same name when they looks like that, when they have the same parameters here, the same types, okay? But we can have two functions that are the same name with different types in parameter. So right now we can easily do something like that. And now, as you can see, oh, sorry. Here I have to, of course, be and and now, as you can see, everything works fine. We can easily run the program. And this thing is called overloading functions, because we are overloading that name, right? We have two same names. And our PC knows which guy to execute, because he's like, hey, I have the double here, so I have to take that function, not that function. He knows which one he must invoke, okay? Or let's make a bit different that function, so we will notice that he's invoking the right function. For example, let's do in that function something like that. We will send to the output every time we'll do something for example, that 2 raised to the power of 3, something like 2 raised to the power of 1 is 2, 2 raised to the power of 2 is 4, 2 raised to the power of 3 is 8. So we are going to send to the output all these steps, right? And how to do that? Let's create, for example, temporary variable I, which will take, which I will assign to 0. And right now I will do something like that. When I is lower than exponent, and I will increase I right now. So I'm going to have the additional number, because we can't use the exponent right now, because we want to start from the low lowest exponents, and let's do something like that. Cout, and so we are raising the base, and our temporary base is here, right? So we are going to write something like that. Temporary raised to the power of, and our actual power is here, so that is equal to, and the result is here. And now if I do something like, for example, that, you'll notice that so something is wrong, because 2 raised to the power of 1 is not for sure. We should first do it that way, and now you will notice that the results are fine, but that result is not good, because 2 raised to the power of 6 is not 128. So because of that, we are going to also do something like that. If I is not equal to e, we can multiplicate, but otherwise, so when it's the last run, just do not do it, and now the result is also fine here. Okay, so but the most important thing is that you should notice that when we are doing something like that, we are invoking that guy, right? Because our PC knows, hey, there is integer, so we are going to use that function. But when I use something like that, I have double first, so hey, I will use that function. So I didn't send the steps to the output. And you might be now like, hey, but you could do it that way, because double is wider than integer and everything would work fine. You could do something like that. And hey, look, we have the result still. Why did you tell me about that? Because we were operating on integer, and why send integer to double? Why take more memory? And maybe sometimes there were some operations on integer that will be faster. So that's why overloading is good idea. So I'm going back to that place. Now everything works fine, right? When I do something like that, RPC knows which guy we want to choose. Okay, that's all. Thank you very much.